In sections 2 and 3, we're looking at triangle congruence. And if we remember from earlier, congruence is when two things are exactly the same shape and size. You can flip it, turn it, mirror it, anything like that, but it's when they are the same size and shape. And here we have two triangles here on the left. And these two triangles are the same size and the same shape. And you can see that we have angles that line up with each other. We have this angle and this angle. This one here lines up with this one down here. B and F line up, and then C and E line up. We also have sides that line up with each other. If you want to prove that two triangles are congruent, you do not need to know all three angles and all three sides. Because it turns out when you are drawing a triangle, you, for example, could have the three sides. Let's say this is 4, this is 3, this is 5. And this is obviously not drawn to scale here, but when you have a triangle with side lengths of 3, 4, and 5, there is only one way to draw that triangle. Every 3, 4, 5 triangle is going to be exactly the same. Yes, you could rotate them, mirror them, things like that, but they are going to be congruent to each other. So having three sides is enough information. Another thing you could do, if you drew an angle and then you had a side in between, so you knew the measure of this angle, you said this side was length 5, and then you knew the measure of this angle here, there is only one way to complete this triangle. And so knowing an angle, a side, and an angle in a row is enough information to completely draw a triangle, which means that you could draw two of them and they would be identical, they'd be congruent. So we're trying to figure out what is the minimum information you need. Turns out 3 pieces of information is always going to be enough. So let's look at all the different combinations of 3. And what I did here is I iterated through all of the things one at a time in each of the 3 slots. I have 1 slot, 2 slot, 3 slots here. And so I put angle for the first one, and then I did angle and angle all in a row. After that I did angle, angle, and I just changed the last one to side. Well, if I was flipping back, I got to go back to angle for my first one. But now let's change my second one to side. So angle, side, angle. Then angle, side, side. Now I've used up all of my possibilities with angle being first, so I make the first one side, angle, angle, side, angle, side, 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 angle, side, side, side. So the point is that there are lots of ways I can go through and form 3 possible things in a row. And we're going to see which of these is enough to prove congruence and which of these is not. So our first one, angle, angle, angle. Is that enough to prove congruence? If you think of knowing the 3 angles, that will get the shape exactly right. Once you know 3 angles, you can prove the shape. However, knowing 3 angles does not tell you the size, because this could be 10, this could be 5, and all of a sudden this triangle is twice as long in every dimension as this one. So there's a name for that. It's called similar, but it is not congruent. So we're just going to cross that out for now because we're only dealing with congruency, not worrying about similar. The next one is angle, angle, side. When you have an angle, and a side all in a row, angle, skip the side, angle, and then immediate side, you can only draw one complete triangle. One of the cool things about having 2 angles in any situation is that you're automatically going to know the third. So really you effectively get 3 angles when you know 2 because they have to equal 180. So we have our 3 angles, and then by giving us one side we avoid this problem we had up here where we didn't know any of the sides and the whole thing could scale up and down. So angle, angle, side, it's abbreviated AAS, and that is a form of congruence. Next one, angle, side, angle. That was the example we used down here. Angle, side, and an angle all in a row. Here you can see from the example, let's abbreviate it, angle, side, angle, ASA. You'll use these abbreviations more than you'll use the full names. We have an angle, and immediately after that we have a side, and immediately after that we have an angle. So all in a row, angle, side, angle, and there's only one way to draw this triangle once you know the angle, the side, and the angle. One of the things that you'll notice as we get down to our next few, angle, side, side, and side, angle, angle, is that they're repeats of one below. So angle, side, side, and reading it backwards, side, side, angle, are exactly the same. So these two here are exactly the same, so we're actually just going to cross that one out. Same thing here, side, angle, angle, same as angle, angle, side above, so we're going to cross that one out. If you're wondering why we picked angle, side, side to cross out, look at its abbreviation and you'll understand. So, jumping down to side, angle, side, here we have a side, the angle included in between, and then the additional side on the other end. And when you do this, there's only one thing you can do on the last piece, and that is to draw your remaining side connecting those two, and it's always going to form the same angles when you draw that connection. So side, angle, side is a valid form of congruence, SAS. SSA is an interesting form because it doesn't always work. SSA, when you have an angle, and then you do a side, and then you do this next side after it, there's actually two possibilities in some triangles. Sometimes there's one, sometimes there's none. When you have a side and a side following each other immediately, that last side could be folded out, or you could do the angle, the side, and the final side folded in. And you can see that these two are not the same triangles. They are not congruent. So you need to be careful with side, side, side. Side, side, side is something I would say for now don't try to use. So we're just going to say not always guaranteed congruence. So we're going to skip that one. And then finally side, 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 like the example we used earlier. You have one side the same, one side the same, second side the same, and then third side the same here. And there's only one way to draw those triangles. Even if you flip it, turn it, mirror it, whatever, it's always going to end up looking the same. So that is SSS. The special case of the side-side angle that will be an exception to that rule we said above, where you could end up with two of them, is when you form a right triangle. So if you form a right triangle, you get a right angle as your first angle, followed by a side, which would be a leg, and another side in a row, which would be the hypotenuse. So this is often called hypotenuse leg, or HL congruence. It's really just a special form of that side-side angle. When you form a right angle up in here on this first angle, you don't run into this problem of having two possible triangles. When you have a right angle, there's only one way to do it. That's why HL is going to be a good form of congruence that you can use. If you notice you have a right triangle, you have a hypotenuse and a leg, you can just call it HL.